Whenever scientists, researchers try to analyze the physics behind a natural phenomena, they follow a process. This process we call it as scientific methods. Electricity and magnetism was unified by Maxwell and it was given as electromagnetism. Force is a pull or push that causes the object to change its velocity or shape. Hello everyone, hope you all are doing good. I am Nishmananjama, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear students, today I have come up with session that is Chapter 1, Physical World. This is the first chapter in our first PUC Physics textbook Part 1. So, what we will be studying in this session, I will be telling you a detail about what is physics, from where did this word physics originate from, what is the scope of physics, how physics and technology is benefiting our society, and also I'll be telling you the nature of physical laws, that is, I'll be talking about the conservation laws. So dear students, up to 10th standard, you might have got a preliminary idea about what is electromagnetism, what is electricity, what is motion, what is force, what is light energy, heat energy under the subject science. All these topics, students, are related to physics. Physics being the basic discipline under a category natural science. So students, let us first try to understand what is science before we brief up what is physics. So what do you mean by science? For example, students, imagine you are in a dark room. You'll turn on the switch, the bulb starts to glow. So what is this mechanism? I want to know why the bulb starts to glow immediately when you turn on the switch. You have fan. Fan starts to rotate immediately when you turn on the switch. Why the fan is rotating? I want to know what are the mechanism behind this. The sky is blue, the star is twinkling. I want to know why is it happening this way? What is the reason behind this? Science. Science means to know. Science is originated from a Latin word scientia, which means to know or knowledge. And it is also obtained from a Sanskrit word which means Vignan, and also from an Arabic word which means ilm. All these has a similar meaning, knowledge. So science is a systematic and organized attempt to acquire knowledge about the surroundings through observation, experiments and verification. Students, what do you mean by systematic and organized? What do you mean by systematic and organized? Say for example, if a teacher asks you to write a number from 1 to 10, will you write 1 and 10? No, right? You'll always follow an order. You write 1, 2, 3, up to 10. So that is systematic and organized way of writing numbers. Say for example, you're writing alphabet from A to Z. Will you write only A and Z? No, right? You'll always write A, B, C, D up to Z. That is the systematic and organized way of writing English alphabet. For example, if a student wants to learn how to frame a sentence, how will you frame a sentence? First you will learn English alphabet A to Z. Then you learn how to frame word. Once you learn how to frame word, then you will frame a sentence. That is how you learn English. Even science has a systematic and ordered way of carrying out things. Science is derived from a Latin word scientia, which means to know. Students, this is all about a basic introduction about what is science. Science is experimenting, exploring and predicting the things around us and the curiosity to know about world and unraveling the secrets of nature. This is the first step for the discovery of science. So physics is the basic discipline in the category of natural science. Let us try to understand what is physics. So physical world, what is physics? So here you can see the images of many natural phenomena that occurs in and around you. So physics. Physics was derived from a Greek word which means physis. Physis means nature. So how will you define physics now? Physics is a study of nature and natural phenomena. Physics is a basic discipline in the category of natural science, which also includes other disciplines like chemistry and biology. So physics is a study of nature and natural phenomena. Students, what do you mean by the term natural phenomena here? Imagine when you tell natural phenomena. So the color of rainbow, the sky is blue, twinkling of star, the regular repetition of day and night, the annual cycle of seasons. There are many such natural phenomena around us. The science behind these are studied through physics. Whenever scientists, researchers try to analyze the physics behind a natural phenomena, they follow a process. This process we call it as scientific methods. So this scientific methods has 5 interconnected steps, students. So the first step is systematic observation. So scientific methods has 5 interconnected steps. The first is systematic observation. What do you mean by systematic observation? So here let's take an example. Let's talk about the famous scientist Sir Isaac Newton, who gave us the universal law of gravitation. So the falling of apple from tree to the ground, that was Newton's clear observation. Everything starts with an observation. That is systematic observation, students. The second step is controlled experiments. What do you mean by controlled experiments? Anything that you notice or you see in and around you might have happened by chance. So it is also important to perform series of experiments just to ensure that this phenomena keep happening the same way. That is controlled experiment. Once you observe, you perform series of experiments just to ensure this phenomena keep happening the same way. The third step is, what is the third step? That is qualitative and the third step is qualitative and quantitative reasoning. What do you mean by qualitative and quantitative reasoning? Students, it's always important to validate the entire experiment with valid data as well as with invalid data, just to know how things work and how things will not work. That is qualitative and quantitative reasoning. The fourth step is, students, mathematical modeling. The fourth step is, students, mathematical modeling. What do you mean by mathematical modeling? Before the law, universal law of gravitation given, first came the mathematical representation of universal law of gravitation. That is nothing but F is equal to G m1 m2 by r square. So before the law universal gravitation was given, first came the mathematical representation of the law of gravitation given by Newton. What is the last step, students? That is the final step. That is nothing but verification or falsification of theories. The fifth one is verification or the fifth step is verification and falsification of theory. What do you mean by this? This is the final step that is required to ensure that this law holds true universally for all the objects at all the places. This universal law of gravitation given by Newton was verified thoroughly and then only it was put forward as a law. However, several years later, when Einstein's theory of relativity came into picture, it in a way questioned universal law of gravitation. So students, physics is the study of nature and natural phenomena. You got to know what all the natural phenomena and how the scientists follow a process, that is systematic method to come up with new theories. The 5 interconnected steps are: first is systematic observation, second is controlled experiments, third is qualitative and quantitative reasoning, fourth is mathematical modeling. Fifth is verification and falsification of theory. So next, physics has two basic principles. One is unification and second is reduction. So what do you mean by unification? Unifying things. Many natural phenomena is unified by one law. So let us see this more clearly. So falling of apple, moon revolving around the earth, pendulum swing, all these natural phenomena is unified by one law, that is law of gravitation. So let's take the second example. You have electromagnetism. So what is electromagnetism? Electricity and magnetism was unified by Maxwell and it was given as electromagnetism. So electromagnetism is electricity plus magnetism. So electricity and magnetism was unified and called as electromagnetisms. So, and similarly, there are many such terms which can unify many natural phenomena and can be put forward. That is what we call it as unification, unifying things. Okay, and what do you mean by reduction then? What do you mean by reduction? What is reductionism? Breaking up of complex problem into simpler parts is known as reduction. So let me explain this with a small example. Say I have a ball in my hand, I have two blocks and I have a simple pendulum here. I'll apply some force to the ball go hit the block 1 and block 1 in turn will hit block 2 and that will go hit the pendulum. Pendulum swings to certain height. Now I want to calculate what is that height. So it is a lengthy problem, right? It's a complex problem. I can't solve it in one stretch. So what I will do, I'll break it into parts. First I'll calculate what was the force that I applied. So that in turn hit the block 1. So block 1 hit the block 2. I need to know what is the collision there. Then I'll calculate what height did the pendulum swing. I'll break the complex problem into simpler parts. That is what we call as reductionism. So reduction means breaking of complex problem into simpler part. So physics has two basic principles, unification and reduction. So you got to know what is unification, unifying things. So what is reduction? Breaking complex problem into simpler part and solving them is reductionism. So next we have scope of physics. Students, to understand the scope of physics, students, you need to understand the two subdomains coming under the scope of physics, that is macroscopic and microscopic. So these macroscopic and microscopic was classified based on the magnitudes of physical quantities. It was so this scope of physics has two subdomains and these two subdomains was classified based on the magnitude of physical quantities. So some of the physical quantities are length, time, mass, etc. So these are the few physical quantities, students. So based on the magnitude of physical quantities, they are divided into macroscopic and microscopic. If the magnitude of physical quantity is large, then we call it as macroscopic. If the magnitudes of physical quantities are minute, then we call it as microscopic. So macroscopic means large quantities, microscopic involves minute quantities. So microscopic involves the study of terrestrial bodies, celestial bodies, temperature, energy, motion of planet, etc., etc. More specifically, the disciplines that come under classical physics such as mechanics, thermodynamics, electrodynamics and optics, we group it as classical physics. So macroscopic is more specifically nothing but the classical physics. What do you study in mechanics then? So mechanics involves the study of motion, general particles of system, Newton's laws, all these we study under mechanics. It is nothing but the problem in that includes time, speed, distance, all these come under mechanics, students. Next you have thermodynamics. What do you study under thermodynamics? In this branch of physics, you will learn what is temperature, what is heat. All these topics you will be studying in thermodynamics. Problems containing like what is the efficiency of heat engine, what is the efficiency of refrigerator. All these type of problems you will be studying under thermodynamics. The third one is electrodynamics. In this branch of physics, you will study what is charged bodies, what is electricity and what is magnetism. All these topics will be covering under electrodynamics. Scientists like Faraday, Ampere, Maxwell, Oyster have contributed to this branch of physics. In optics, in this branch of physics, you will study the phenomenon of light. All these branch you will be seeing in under classical physics. So, once you're done with classical physics, next you have microscopic. What do you mean by microscopic? You got to know. If the magnitude of physical quantities are small, then we group it as microscopic domain. So under this domain, you have modern physics that involves the study of structure of atom, matter, nuclei and their interaction with electron, proton, neutron, etc. etc. The currently quantum physics has been accepted as the proper framework to explain these phenomena. That's why this is also called as modern physics. We group microscopic domain as quantum physics. So this is the scope of physics, students. Scope of physics is always vast. This is about the scope of physics, students. There is no stop to understand or to explore more in science. It's always a continuous process. So it's grouped into two subdomains, microscopic and macroscopic, based on the magnitudes of the physical quantities. Some physical quantities are length, mass, time, etc. So macroscopic means the large quantity. If magnitude of physical quantity is large, then we group it as macroscopic, which is also called as classical physics. If the microscopic means the magnitude of physical quantity is minute, then we call microscopic. It is also called as quantum physics. This domain was present way long before, but this microscopic domain was given just recently. So this involves the study of atoms, their interaction with proton, neutron, etc. etc. All these topics which just came recently are grouped under microscopic, which is currently accepted as quantum physics has a proper framework to explain these phenomena. This is the scope of physics, students. Next, you have physics, technology and society. So what is this physics, technology and society, students? Just think about it. For example, you are sitting at home and you're talking to your friend in the cell phone who is at some other part of the country. You're watching the live telecast of games that is taking place at other part of the world. So how is this possible? So the phenomenon beside these fascinates us to study physics. Even in the field of technology, take the example of technology. First we had horse cart, now we have cycle, then we had motorcycle, then we had car, now we have aeroplane. There is the improvement in the technology in each step as we go higher and higher. So this physics and technology is benefiting the people of our society, which is in turn helping out the society. So physics and technology has a deep interconnection. So let us explain how physics is related to technology and technology is related to physics. So let us take an example. Sometimes physics give rise to technology and technology sometimes give rise to physics. How is this? Here you can see physics giving rise to technology. So let us talk about computers, which you can see all around the world. It is just like an computer age. Computer is a technology, right? From where did this technology come from? Just think, where did this technology come from? From the silicon chips. It's an integrated circuits. What are these? These are physics, right? That is how physics is giving rise to technology. Here you can see technology giving rise to physics, students. Students, let's take the example of heat engine. Heat engine is a technology, right? So from the heat engine came the entire theory of thermodynamics. In order to increase the working and efficiency of heat engine, a new branch for physics, that is thermodynamics, was introduced. Here we saw how physics giving rise to technology, and here we saw how technology is giving rise to physics with the example of silicon chip and heat engine. So this is how Physics and technology is benefiting our society. So physics plus technology is equal to society. So next we have fundamental forces in nature. So till now we spoke about nature, natural phenomenon, etc. There is one thing that play a crucial role. What is it? It is force. You might have learned what is force in your junior classes. Here in this session, let us not get into detail of what is force, but in this session, we'll try to get a quick understanding of what is force. The force which is naturally existing, like they are there in nature. Those force we call it as fundamental force. What are its types? Before that, let me define what is force. Force is a pull or push that causes the object to change its velocity or shape. So what are those four fundamental forces, students, which are naturally existing in our nature, like they are there in our nature? So next we have fundamental forces in nature. The first one is strong nuclear force. The second one is weak nuclear force. Third one is electromagnetic force, and fourth one is gravitational force. These are the four fundamental forces in nature. Let us discuss them one by one. First, let us try to understand what is strong nuclear force. It is the strongest force in nature. It is the force that binds protons and neutrons in the nucleus. It has a range of 10 to the power minus 15, which is average diameter of nucleus. What do you understand by this? Strong nuclear force is strongest in nature, and it binds the protons and neutrons in the atomic nuclei, and it has a range of 10 to the power minus 15 meters, students, which is the average diameter of nucleus. And next, second one, we have weak nuclear force. What do you mean by weak nuclear force? It is weak compared to strong force, has a range of 10 to the power minus 16 meter, which is 1% of diameter of nucleus, and its strength 10 to the power minus 13 times compared to electromagnetic force. So what do you understand by this? Weak force, it also exists within nucleus. It is the force by means of which certain elementary particles interact. We see this force in case of radioactive decay, all these phenomena. If you don't know what is radioactive decay, don't worry. We will be learning what is radioactive decay in our upcoming session. So, weak nuclear force is the force by means of which certain elementary particle interacts. We see this weak force in case of radioactive decay, and you can see it has a range of 10 to the power minus 16 meter, which is 1% of diameter of nucleus, and it is weak compared to electromagnetic force. The third one is electromagnetic force. What do you mean by electromagnetic force? So it is a combination of electric as well as magnetic force, students. It is the force that occur between charged particles. So it is the second strongest force after strong nuclear force. And electromagnetic force has infinite range. You can see it has infinite range, and its strength is 10 to the power minus 2 times compared to strength of strong nuclear force. So this is about electromagnetic force, students. You can read here. It is a force between charged particle. It is the second strongest force after the strong nuclear force. It has infinite range, and its strength is 10 to the power minus 2 times compared to the strength of strong nuclear force. The last one, the fourth one, is gravitational force. So what do you mean by gravitational force? It is the weakest force having very large range, and its strength is 10 to the power minus 39 times compared to electromagnetic force. So it is the weakest force among all the four fundamental forces, and gravitational force is always attractive and is the force that acts between two objects by virtue of their mass. We'll study detail about gravitations in our upcoming sessions, that we have a chapter on gravitation in your physics NCERT textbook for first PU. So these are the four fundamental forces. So here I have put these four fundamental forces in a tabular column, so it will help you in a better way. So first, strong nuclear force, weak nuclear force, electromagnetic force, and gravitational force. I have written what is the relative strength, what is the range, and operates among for the four fundamental force. You can see strong nuclear force, strength is 1 and range is short, nuclear size that is 10 to the power minus 15 meter, and operates among nucleus, heavier elementary particles. Second is weak nuclear force, whose strength is 10 to the power minus 13 and range is very short, subnuclear size 10 to the power minus 16 meter, and some elementary particles like electron and neutrino. Third is electromagnetic force, that is 10 to the power minus 2. It is infinite range and operates among charged particles. Next you have gravitational force, students, whose strength is 10 to the power minus 39 meter and range is infinite and operates among all objects in the universe by virtue of their mass. So these are the 4 fundamental forces that I have discussed in the previous slide, and I have put it in the form of tabular column, so that will help you in a better way to understand these forces, their strength, range and operates among. So this is the order that I have written the 4 forces from the strongest to the weakest in the decreasing order. First is the strong nuclear force is the strongest force, and second comes electromagnetic force, and weak nuclear force last is the gravitational force. So strong nuclear force is the strongest force in the nature and gravitational force is the weakest force in the nature. So here I have a question for you all. Among the 4 fundamental forces, which are the short range forces and which are the long range forces? Short range forces, since strong nuclear force and weak nuclear force operates within the nucleus is itself small, it has short range, right? So strong nuclear force and weak nuclear force are short range forces. So electromagnetic force and gravitational force are the long range forces. Please keep this in your mind. So next, unification of forces in nature. So you can see a tabular column where the name of physicist, year and achievement in unification. So these are the few scientists who have unified many phenomena and given one theory. So as I have explained earlier in the previous slide, take the example of Maxwell, who unified electricity and magnetism and gave it as electromagnetism. Similarly, these are the few scientists you can go through. You can see Isaac Newton, 1687, unified celestial and terrestrial mechanism, showed that the same law of motion and the law of gravitation apply to both the domains. That's the falling of apple, revolving of moon around earth and pendulum swing. All these phenomena is explained by one law, that is law of gravitation, that is unifying many things under one framework. So these are the scientists who have worked towards the unification of theories, unification of phenomena. You can go through this slide. Next you have conservation law. Conservation law, what do you mean by conservation law? Conserved means stay same, stay constant, that we call it as conserved. So any physical quantity that remains unchanged before and after the reaction with respect to time, we call that as conserved quantities. So the law that governs these conserved quantities are called conservation law. Conserved quantity means, let us consider we have some physical quantity which is undergoing certain process. So that physical quantity has to stay same even before the reaction, even after the reaction with respect to time. Those physical quantities, we call it as conserved quantities. The law that governs these conserved quantity, we name it as conservation law. So here are the 5 conservation law, students. The first one is law of conservation of total energy. What do I mean by law of conservation of total energy? Take the example of bulb. The moment I turn on the switch, the bulb starts to glow. So electrical energy is converted into light energy. The total energy is conserved. So that is law of conservation of energy. Similarly, you have conservation of electric charge. What do you mean by conservation of electric charge? For example, I'll take the example of sodium chloride, NaCl. So the net charge before the reaction is 0. When it undergoes a process, it is converted into Na plus and Cl minus. So what is the charge here? Plus 1. Plus 1 and minus 1. So what is the net charge now? It is 0. So the net charge before the reaction and after the reaction, it is 0. So total charge is conserved. This is one example for conservation of electric charge, sodium chloride. Before the reaction, the total charge was 0. Even after the reaction, When it undergoes a reaction, it is split into Na plus and Cl minus. When you calculate the net charge, it is again equal to 0. So the third one is law of conservation of linear momentum, and the fourth one is law of conservation of angular momentum, and the fifth one is law of conservation of mass. You need not have to go into detail about what are these, but you should know what are conserved quantities, what is conservation law in its types. Your first few textbook does not involve the detail about what are these laws, but you should know what are the 5 conservation laws. So this is about conservation law, students. Next, few milestones in the development of physics. Here you can see the name of the scientists who have worked to the development of physics, who have contributed many theories, technologies towards physics. So you know who is Kepler? Kepler gave the law of planetary motion, and Galileo Galilei gave the law of inertia and telescope, and Isaac Newton came up with law of mechanics, gravitation and reflecting telescope. These are the scientists who has contributed towards physics in the development of physics. You can go through, these are the scientists and these are the theories given by the respective scientists. Here you can see Röntgen gave X-rays, Becquerel gave radioactivity, J.J. Thomson gave electrons, gave the theory of electrons. Similarly, there are many physicists who has contributed towards science. You can go through these slides. Here are the few scientists who have contributed in development of physics. For example, C.V. Raman, who came up with Raman effect. Similarly, you can see Enrico Fermi, who came up with nuclear reactor, which has helped in the development of physics. So these are the few scientists who has contributed to the development of physics in uplifting physics. So in today's session, students, let's quickly summarize what all we studied for today's session. So in today's session, we started with what is science. What is science and from where did this word science originate? Science originated from a Latin word which means scientia, and in Sanskrit it means vignan, and in Arabic it's ilm, which means to know, which gives a similar meaning called as knowledge. So science, physics is being one of the basic discipline in the category of natural science. We studied what is physics. Physics means physis, which is derived from a Greek word which means nature. So physics is the study of nature and natural phenomena. What is natural phenomena? The twinkling of stars, the color of rainbow, why the sky is blue in color, the regular repetition of day and night, many such natural phenomena we always see in and around us. So the science behind this is studied through physics, and whenever scientists, researchers study, analyze physics behind a natural phenomena, they follow a systematic method. This systematic method has 5 interconnected steps, students. The first one we saw was systematic observation, second one was controlled experiment, third one was qualitative and quantitative reasoning, fourth one was mathematical modeling, fifth one was falsification and verification of theories. Next we saw 2 basic principles of physics, that is unification and reduction. What is unification? What is reduction? What is unifying and what is reductionism? Breaking complex problem into simpler parts. Next we saw what is the scope of physics. That is, if you can understand the 2 subdomains of physics, that is macroscopic and microscopic, you can understand the scope of physics, which is very vast. So macroscopic means large quantities, microscopic means minute quantities, and which is also called as classical physics and it is termed as quantum physics. What are all the subdisciplines that come under each branches, each domains? That is scope of physics. Next we saw what is physics, technology and society. How physics give rise to technology and how technology sometimes give rise to physics. How they are interconnected. What is the strong bonding between them with an example. Physics plus technology is equal to society. That's how physics and technology is benefiting people of our society. That is, we studied in our physics, technology and society. Next, we saw the 4 fundamental forces in nature, which are those strong nuclear, weak nuclear, electromagnetic force and gravitational force. We studied them in detail. And next we saw unification of forces in nature. How scientists unified different aspects, that is different phenomena under one branch. Example, Maxwell unified electricity and magnetism and gave electromagnetism. Similarly, I have mentioned few scientists who unified, who contributed in unifying the theories. Next we saw conservation laws. What do you mean by conserved quantities and conservation law? The 5 conservation laws. That we studied in the conservation law of nature. Next, we studied about few milestones in the development of physics. So how different scientists have contributed with different theories and technology in uplifting or in developing physics. So that's all about today's session, students. I hope it was interesting. I'll come up with more physics session. Until then, see you all. Take care. Have a good day. Thank you.